All right, so we're taking a look at learning target 1.1, so some practice to make sure we understand what we're doing here. So the whole point in this learning target is to understand what a solution looks like in an inequality. Okay, so the whole point of an inequality is that there's more than one answer, right? And when you look at it, okay, you have to be able to visualize that. And so visually what we do is, as you can see, we've got a darkened or shaded portion, okay? And the shaded portion represents all the possible answers, okay? So every single point here is a possible answer in the shaded region, okay? So I could just keep drawing points anywhere, and all these points are solutions to this inequality. All of them work. And what does that mean? Well, let's take one for this -2, 1. X is -2, y is 1. So if I take it and put it into this inequality, so my x value is -2, my y value is 1. So if I simplify this, I'd have 1 is greater than -2 plus 1 is -1. Is that true? Yes, that's what it means that it's a solution, that it works, that it makes the inequality work. Okay. Now the places where the non-shaded area, these are non-answers, okay, or not solutions. Okay. So any point out here in the non-shaded isn't going to be a solution. So I could try one, +3, -3. If I do the same thing and plug it in, so -3 for y, +3 for x, I get -3 is greater than 4. That is definitely not true. So in the unshaded area, they make the inequality false. Okay? So that's all we're doing, is taking a look at these inequalities and seeing which is true and which isn't. Okay? So all we do is draw a point that's a solution. And you can even write it too. Alright, now if we look at number 2, same idea. What's a point that is a solution? Well, I look at this shaded area, any of those points. Okay. Now here's something to note. Okay. These lines here are dotted. This one's solid. Okay. So what does that mean? Well, let's test it out. So we said it to be a solution. So let's try this 0.20. It looks like it's in the shaded area, but to be a solution, it has to make the inequality work. So if I plug in 0 for y and 2 for x, I get 0 is greater than 2 minus 2 is 0. Is that true? No, that's not true. Okay. So when the line is dotted, the line serves as a barrier, but the line is not part of the solution. Okay? Because that's not true. Now, if it were equal to 0 is equal to 0, in that case, that's when we have a solid line, like this one. So number 3. So if I took this and tested out this point -2, 1, okay, so for x, I'd have -2, for y, 1. So I'd have 1 is greater than or equal to a -2 minus 1. First negative from there, second negative from there. So 1 is greater than or equal to +2 minus 1, which gives us 1 is greater than or equal to 1. So see, on the line is where it's going to be equal to. And in the shaded portion is where it's either greater than or less than, depending on the problem. So again, the dotted line, not a solution. Solid line, a solution. Okay, and again, when I'm marking a point for a solution, it can go anywhere as long as it's in that shaded area. All those points will satisfy the inequality. That's really all there is to understanding an inequality. Now, something to mention is, I could draw a point out here. Is that a solution? Well, you've got to remember the line with the arrows means that it extends. Okay, so that shaded area is going to extend on that whole half of that graph. It'll just keep going. So as long as it's on that half of the graph that's shaded, it is a solution. So a point clear out there would definitely be a solution. Okay? So you got to remember that this line kind of cuts the coordinate plane in half. And half of it is an answer, and half isn't. Answer, non-answers. So that's all we got to do, is just plot a point on each of these where there's an answer, where there's a solution. So it's pretty easy to tell when we have solutions and when we don't. Okay? That's really all there is to it. As long as it's on that shaded portion, you know it's an answer. And so when we graph them, that's what we try to do, is find where the line is and where it's shaded. Okay, that's all there is to it. That's all there is to it. Now, if you wanted to get really fancy, you could do like a circle. And let's say it was shaded on the inside. Okay, so where would a solution be? Anywhere on the inside. But if I had another circle and it was shaded on the outside, then the solution would be anywhere on the outside. Okay, so you can't even get some crazy looking graphs. And think about the exponentials, right, that we've been graphing. What if I did an exponential as an inequality? Okay, whichever way it's shaded, again, it's where the answer is. Places that aren't shaded, that's where there's no answer. All right? So that's what we do, I guess, to sum up again. Okay, a solid line is less than or equal to, greater than or equal to, and where it's shaded, those are the possible answers. Okay, for a dotted line, less than or greater than, it's just where it's shaded. So this is shaded and line. This is just shaded. All right, there we go.